Hello guys, welcome back to the Logic Talks. In this session, we will be seeing one more question on DFA. So let us just move on to the question. So the question is to design a DFA over the input alphabet 01 such that it accepts all the binary strings whose decimal equivalent is divisible by 5. So for example, 101, 0101, 1010, 1111, all these are divisible by 5. So these should be accepted by the DFA and remaining all should be rejected by the DFA. So let us move on to the solution then. So as we can see in this table, the decimal numbers ranging from 0 to 10 are given in column number 1. Their binary equivalent is given in column number 2, and in column number 3 we are having the remainder that we can get by dividing the number by 5. So the range is between 0 to 4, and the states that we have to make for our DFA, that is mentioned in column number 4. So as we can see that the number of states that we have to take will range from Q0 to Q4. So we will be having 5 states here. So we have already seen the detailed version of this of such questions in the previous video. So in this video, we will be focusing on the shortcut method to do such questions. So here as we can see that we are dealing with the division of 5. So here we have to make 5 states, that is Q0, Q1, Q2, Q3 and Q4. So now let us make a transition table for this. So in order to make the transition table, we will be taking 5 states, that is Q0, Q1, Q2, Q3 and Q4. So we will be making Q0 as the initial state and final state as well, because Q0 is dealing with the 0 remainder, and in this question we have to accept the binary string whenever it is exactly divisible by 5, means that whenever we are getting remainder 0. So here we will be making Q0 as the final state also. So and remaining, as you can see that states Q1, Q2, Q3, Q4, all these are mentioned in column number 1. And if you look into the column number 2 and 3, we are having we are dealing here with the inputs that we have to give, that is 0 and 1, and we can just write it like this: Q0, Q1, Q2, Q3, Q4, and then again we will start with Q0, Q1, Q2, Q3, Q4, and this is our transition table. It is complete here now. Then we will be making the transition diagram out of this. So let us see the transition diagram also. So here we are having all the 5 states, and Q0 is the initial state and Q0 is final state also. And then Q0 on getting 0 as input, it is moving to Q0 itself, as we can see from the transition table also. And Q0 on getting 1 as input, it is moving to state Q1. And Q1 on getting 0 as input, it is moving to state Q2. And Q1 on getting 1 as input, it is moving to state Q3, as we can see in the transition table also. And Q2 on getting 0 as input, it is moving to state Q4. And Q2 on getting 1 as input, it is moving to state Q0. And Q3 on getting 0 as input, it is moving to state Q1. And Q3 on getting 1 as input, it is moving to state Q2. Q4 on getting 1 as input, it is moving to state Q3. And Q4 on getting 1 as input, it is moving to state Q4 itself. So this is our complete transition diagram. So it will be accepting all the binary strings whose decimal equivalent is exactly divisible by 5. So with this, we are done with this question. But sometimes you will be getting questions where your DFA should accept all the strings whose binary equivalent decimal when mod by 5, it is giving you like 4. So in that case, you just have to do a slight modification in this transition diagram, that you just need to change the final state to Q4 then. If it is like some number mod 5 should be equal to like 3, in that case, you just have to do that. You have to make Q3 as the final state then. If it is like any binary equivalent decimal when mod by 5 is giving you 2, in that case, you just need to modify the final state to Q2 then. If it is 1, in that case, you just need to modify final state to Q1 then. Rest, everything will remain same. You just have to modify the final state. That's all for this question. I hope it is clear to all of you. For more such questions, you can like, share and subscribe the channel. Thank you. Bye.